got these feet on our operating table, which wouldn't be on a real operating table, so I have to navigate a little bit carefully. So this, again, it's not heavy. It's designed so that when it's standing, the wheels aren't touching the floor. So the wheels don't take the weight of anything except this. So when you lift it 5 degrees, it's now on the wheels. And also it's very useful because you don't, lining this up can be considered a fiddle. But if you just pick it up, it aligns it straight, just under gravity. So you can see this tongue part of the patient support plate goes into a slot in there. It engages in here, and this is quite an important feature. That's how it follows the operating table height. Literally goes up and down. So this stays with the operating table, and it slides up and down inside there. So if the surgeon changes height during surgery, the most you would have to do is follow the height to keep the patient's leg angle correct. So for minor adjustments you wouldn't bother. But
so that automatically adjusts when he gets hooked up because you don't have to.
Move.
All right, gotcha. You don't have to do anything with the table prior.
no. But what you have to do is you have to preset the table height so that it's easy to push this in.
After you get the boot on the patient.
Well, actually you would do it even before the patient goes on it.
Oh, okay.
And if in doubt, have it a little bit higher, because when you slide it in, you can always have somebody helping you. You can always do this.
You can't go down.
You can't go any lower. Yeah.
Gotcha.
But this curvature here, it's all in our patent. This is so that in the event that there's some sort of surgical emergency, say the anaesthetist says the patient's about to vomit or something, and they want to tip them head down, okay, this can accommodate 20 degrees of reverse Trendelenburg and 10 degrees that way. So you see, by doing that, effectively the table is tipping down that way by that amount. So it can accommodate all of that without any problem. Okay so far?
Yep.
So for ease of, because we've got more space this side, we're going to do the right leg. So to change the leg over, we just unclamp that, tighten it up again. And these are indexing levers so you can position them anywhere it's convenient and out of the way. So that's now set up for the right leg. So we wheel that in. The next stage is, because the patient won't be right up against this point, you then slide the patient down. That would be on there. Where did the boot go? Thanks. So you slide the patient down by taking both legs, and they'll have them on a sheet or something normally. They know how to do that. It's all normal practice. And then this is free to slide. So you bring the two together, and literally that drops in there and locks. And to disengage it, you lift this pin and push it that way.
Pushed it back.
Yeah. So you can see how it engages in there. So the pin goes up through there and into this space here. Now, this freedom and this freedom is all deliberate. It's not sloppy engineering. The arch, for example, has got a very complex spherical bearing here. It's a beautiful bit of engineering, but it's because it's a trauma table. It's based on a trauma table. It's designed, well, it invites you to lock the spherical bearing. Now, if you lock it off axis, and it's an osteoporotic old lady, and then you apply traction, guess what? You're going to fracture her ankle. Ours is designed so it will always line up, straight line from the perineum, so the leg will just pull in here without any lateral tension at all. And that's deliberate. And everything about the design is, each bit on its own may seem a little bit slack or a little bit flimsy, but when the patient is on it, it's absolutely rock solid. Because this doesn't move like this at all when the patient's leg's in it.
So once the leg's in there, there's no tightening of anything there?
No, because it just self-aligns. It's deliberate. You can see it's engineered in because you can see we've got a central section which is the good fit on the pin, and then this clearance here and here is what gives you the side-to-side angular. Oops. So when you've got the patient on there and they've pulled them down, you just pull back with a little bit of tension and then lock that.
So is it just a turn to unlock and unlock?
So you see here, come and look here, that shows green is unlocked and red is locked. Okay? That's not the same everywhere else on the machine. The guidance is red means potential to injure the patient. So for example, if you look on that there, you see it says green is locked because it's safe then. Whereas if we unlock that, there's a potential to injure the patient because the leg could fall off.
So why is that one that way?
Because when it's locked, you could be applying traction when you don't want it. You could have strained the patient. So it's just, and similarly with this, red applies traction. You can see this is pulling this way. Green takes it off.
So red's kind of caution on there.
Red's caution in every case. Okay. Red means potential to injure the patient. Green means unlikely to injure the patient. That's about as close as you can get, really. Rather than going through locked, unlocked, and well, why is this one locked? So the patient's on there. You've locked this in a comfortable position. So now we don't need this leg support anymore. So that folds out of the way. And
You only really locked right here, though. You didn't lock anything over there.
correct.
Okay.
Okay. So now the patient's on, in position, ready to start surgery.
You see how that looks?
Now, it'll take, it depends on the team, 15 minutes to prepare the operation site and then to drape the patient. And we recommend using a transparent DHS drape as made by 3M amongst other people. And the transparent drape comes to about here. And then whoever's operating the machine operates it, putting their hands under the drape. So they're not scrubbed, they're outside the sterile zone. But you're only that far from this surgical site, which is here. We also wrap this with a non-woven barrier. So actually, because of that, the machine doesn't touch the patient.
Would they normally put towels in there or something, some kind of protection?
Well, they wrap. Again, they've all got different. Every hospital I've been there,
Yeah.
I've taken their advice. They just tend to wrap it to about 1/4 inch thick.
Okay.
We have looked at putting padding on it, and for the arthroscopy version, it will be padded because the traction loads are high. But we're using such small traction loads, we've never had any problems at all.
Okay.
So once the surgeon's ready to start surgery, he will probably ask for, this is slightly elevated now, so the height control of the beam is this handle round here. I'm going to come round and see.
Is there any label on it at all?
Yeah, it says lock and unlock on it.
Oh, okay, so it doesn't say height or anything.
Now, and this handle is just to hold on to. None of the other equipment has anything to stop this hitting the floor if I let go of it now. The worst that can happen with this is it might slowly hit you in the face if you weren't concentrating. So there's no load or force for the operator to lift. Whereas with the Hannah, the beam is, as I explained, about twice as long. The operator's a long way away from the patient's leg, but the beams are unsupported. If they flip the control lever on the Hannah, it will hit